Welcome back. In the previous video, I discussed on some of the variants of vibration transducers and their application specifics. Let's move on to the next topic on how the data from these transducers could be measured, recorded and retrieved, which is the key to most of the post-processing activities. In the initial days of data measurements around 1950s, not much of importance was given to the recording the data, as many of the data qualification and assessments were based on mostly the overall values of noise or vibration and, for that matter, any of the dynamic parameters such as pressure, strain, force and so on. As the overall technology space grew, the need of recording the dynamic signals and using them repeatedly for further analysis, comparison and reassessing the events became mandatory, and thus arrived the versions of data acquisitions and recording devices. The early 70s saw a surge of analog recording devices, mostly magnetic spool recorders and cassette devices, some of them even claiming that they are digital recording for some reasons. However, most of the magnetic based recording and retrieval of data, analog or digital, suffered from depletion of data quality due to either environmental conditions such as temperature, humidity, fungi, etc., or due to the tape elongation and faults with the tape drive mechanical systems. The digital data acquisition systems, also called the DAQs, came into usage in the early 1980s, and since then have become the most versatile, reliable and widely used systems for real-time data recording and retrieval. Let's now look into some of the credible advantages of DAQs. High quality, repeatable, reproducible data recording. Multiple dynamic parameters can be recorded on independent channels simultaneously. Wide range of signal conditioning options to integrate various types of transducers like vibration, noise, pressure, strain and much more. From 2 channels of recording going up to over 2000 channels is possible in a single data acquisition system. High frequency bandwidth, which is essential to a lot of dynamic measurements, going up to 100 kilohertz per channel, combined with high amplitude resolutions, also called the bit rate. Ever increasing onboard capability of data storage, which is very important when you have continuous monitoring of data and this needs to be recorded. For example, a rocket launch, a lot of parameters are to be recorded simultaneously on multiple channels for long durations. Furthermore, what was once a bulky recording device started becoming all portable with long battery backup, making these DAQs even more practical and field deployable. Overall, DAQs are here to stay and further get more improved, versatile and practical as time progresses. In the next session, we will be looking into some of the basics of noise measurements, units, application areas and more. Till then, take care. We will see you soon.